So in our project house we have a finished floor, and in the last video what I said I would do was I would take us through the whole process from breaking ground to the complete finished floor level. Now I know there are some other videos on this subject bit by bit which shows you the whole process, so this is more of a summary of that process just to put things into perspective. So for context, we are in the build it stage and we are primarily in the foundation stage, although some of it trips over into the frame stage. So when we look at the foundations, the first thing that we actually had to do was take a raw piece of land, of course, and we started to build. The first thing that had to be done was marking out those foundations, and that was done by an engineer. So we had to create a level surface. And so all this information that we need to determine the various levels of the foundations through to the finished floor level are available to us through the building warrant drawings. And there's actually four sets of a set of 4 drawings here which gives us that information. One of the drawings has an elevation which shows you the different levels of the essentially from the mud right through to the finished floor level, and you can see that which I will zoom in for you to be able to have a look at. So in fact, if you've seen the other videos, you will know that we actually had a piece of ground that was actually sloping. Now, not a massive slope, but it had a slope to it. And so what we did was we cut out this here, and we needed to bring it down to approximately this sort of level, and then we needed a flat surface. What this meant, actually probably a bit longer than that, what this actually meant was that we had a good solid ground here, but we had ground here that didn't exist before, because or at least at this level it didn't exist before. So what we had to do was infill that. Now when you infill and you've dug the earth out, it's never as strong a surface as this that's been compacted over centuries, billions of years. So this is fairly loose soil, although it is compacted, it's not near as stable as that. So in order to create the stability for the foundations, what we did was that we had to create a trench fill foundation first of all. So what we did was the foundation itself was going to end up here. So we would actually dig down into this ground here, but this was still going to be unsupported. So what we did was that we created foundations there that essentially with concrete, filling that with concrete, and that was a trench fill foundation. So a lot of concrete in there, which was then used to support the rest of the foundation when we put that in. And you'll see that from some of the pictures that we're showing you. Then we added on top here, as I said, the foundation. Now this was a strip fill foundation. This was reinforced with metal. So first of all, we put down concrete blocks to raise the reinforcement off the ground, and you'll see that from the blocks. But we also put those blocks on top of the concrete that was laid here, because this was all going to be one of the same foundations. And so we put those concrete blocks, we put in one layer of steel mesh, and then a second layer of steel mesh with concrete blocks to separate that, and then the concrete was then poured in over on top of that. And essentially what we were looking to do was to create a sealed unit so as that if the foundations moved, they would move together. And so that was partly the reinforcement of that particular parts of the foundations. Once we had established that base, we then had some ground workers come in fact block workers, These are people who will also put up and have for us, in later videos you'll see this, have put up the walls, the outer skin of the house. So this blockwork is then built out of these foundations. Now this is clearly not to scale. I'm not a great artist, and it's what it is, let's say. So you'll see from the pictures much more clearly. So these blocks are built up, and then what happens is once that's built up, we then fill in the space here. Now, in fact, before we actually fill in the space here, because we're going to have concrete in place, we have to have all the services that are going to come into the house already thought out and laid. So we've got to know where the toilets are going to be, where the wash hand basins, baths, showers, all of those things need drainage. We also need to bring water into the house, so we have to think about bringing that in before we actually lay the concrete on top there. We have to think of any cabling. Electricity has to be brought in. We have to bring in telephone, broadband. I know that's sort of like going out in future years. You probably won't even bring broadband in because it will all be done by satellite. But at the moment we're bringing in cabling, so these things have to be thought of. Where are you actually going to site those things, and and of course they are on the plans, but you need to think about that in advance and to make sure that those channels are put in place. And we do that by laying pipes which are then covered over with pea gravel, and in fact they're laid with a foundation of pea gravel, and then they are given pea gravel on top of that, and that allows them to move as well. Now when we talk about movement, we're not talking about a San Andreas fault type earthquake, but we're talking about minor movements in the ground which would then lead to perhaps cracked pipes if we didn't allow them to have some give. So once we've got those services laid out, and so they'll be inside the foundations, but they have to be exiting outside the foundation walls, we then will pour the concrete. And before we actually do that, we actually then lay a damp-proof membrane. We then put in the reinforcing, similar to we did with the trench foundation, and we put in those steel meshes, again using concrete blocks to raise them up, and a second layer concrete blocks in between, then raising them up, and then the concrete is poured over that, and that creates what you call the oversite. So that creates the base of the foundations, but we're not finished yet. Because once we have that foundation in place, we then need to lay insulation. So again, first of all, a further lower layer of DCP, and DCP, in case you don't understand what that term is, it's damp-proof membrane. So it's essentially to stop dampness rising through the concrete from the ground. So a layer of that is put down. We then put down insulation, and then on top of the insulation we put down a further level of DCP. So the insulation is encased in the DCP. And then round the edges of all the walls within the house we would fit foam, and again this is to allow some expansion. So as it heats up and as it cools down, it's going to need that just very, very small. It's not very big, but it needs that ability to be able to expand. Now, of course, in this situation, we're going to have underfloor heating. So we have to then lay the pipes for the underfloor heating. And this is done by basically laying them in a format that not like a spider's web. What was the best way to describe? It's like they have to return back. So they have to come from a point and then they have to return to that point. So it's almost like a spiral. So they have to be laid in that way, but they also have to be secured. So we secure them into the flooring with little pegs to make sure that they're held in place. Now, before we lay the concrete, we want to make sure that there's no holes in that pipework. And so we pressurize it up and we monitor whether there's any loss of pressure. If there's loss of pressure, that means that we've got a hole somewhere in the system, and we've got to find that and replace that piping to make before we would start to lay the concrete. And then the concrete starts to get laid, and the trucks arrive, so the cement screed, but before they actually do that, should I say, they come and prepare it, and they lay these little sort of, I like to call them like Eiffel Towers. They're not Eiffel Towers, but there's these little structures. And what's in these structures is the ability to have a sort of plunger that goes up and down. And so what they do is they determine what the finished floor level has to be, because it needs to be finished to the threshold of the house. In other words, going outside to the house. Particularly nowadays, because you've got to have disability access, so you've got to have a level threshold. So we have to have that level threshold, and so they determine what that depth of concrete needs to be once we've put everything in place. And they basically move this plunger up to the point where the floor level needs to be. So then when they lay the concrete, or they pump the concrete in there, they know, and they have these scattered all around the particular house, they have these scattered all around the different rooms in the house, and that determines the level of the concrete. So you have this consistency of level throughout without having to try and measure it, which would be almost impossible to do. So that's how they establish that. So what we end up with is a finished floor level. So what I'm going to leave you with now is some footage of them putting the screed in, pumping it in, leveling it, and just keeping it all okay. And I would like to just give a little thanks to Lewis McLean, who filmed this section of the video while I was actually away. So I wasn't actually able to witness it on this occasion first hand. So thank you, Lewis, for doing that.
Thank you for watching, and if you like this, then please subscribe to the channel and share with your friends, and then go on and watch some of the other videos that we have on this channel.